Okay, we'll discuss the good morning, students. We'll discuss the numericals on the simple harmonic motion. So some around 10 or 11 numericals is what I picked up. We'll try to think on them. What best method can be applied here? Okay, we'll start the class. Okay, read the question now. We have a liquid here. This part is a liquid and there's a block. Find the time period of oscillations of the system. Spring force, band force of the liquid also has come into picture. Let me magnify diagram. Here I'll explain it. Okay, now what are the at equilibrium? What are the various forces acting? So this is the liquid. So here the forces. So spring will get elongated. So spring force will act here. Let this be the tension. T naught, I'll write it. All the initial things will write it T naught. And this is mg. The weight mg. And the buoyant force FB naught, I'll write it. Okay, this is the initial equilibrium. When I displace it, when I pull this block a little bit vertically down, the buoyant force will increase. Spring will get elongated further. So then therefore the additional spring forces will be acting. If you want, I'll go for one. I think not needed. So when I displace it further, so initially some say like a h length, h naught length was immersed here. Then if you further press it, plus x, let it be. So x length of the slab or the block inside the liquid will increase. So the buoyant force will increase. Proportionally, the tension will change. Even the spring will also get elongated. So kx naught plus x. So the resultant force when the block is, so here we'll indicate this h. Some other color, let me take it. Some h length is immersed here. So what is the, now for equilibrium, kx naught minus t naught equal to 0. Then FB naught plus T naught minus mg equal to 0. What is FB naught? Is equal to density of liquid, rho L will write it, density of liquid rho L Ag into H. Now when the block is, this at equilibrium. Now in the end, I'll ask you some very good questions. Okay, this we can, of course, we can get the time period. Just will analyze further some basic ideas of the various types of forces here. Now when block M is slightly depressed and released. Find, okay, now we have to you have to find out the time period of oscillation. Slightly depressed by a distance x. Everything I'm putting here and released here. So then what is the net acceleration? So it will be, this will start accelerating up. Then this will also accelerate because they're connected by common string. So both will have same acceleration. So then the resulting equation will be kx naught plus x minus t naught equal to me. Then the new buoyant force FB minus t minus mg equal to me. So what is the new buoyant force will be rho L Ag H plus x. I think we can eliminate with the initial things all. So this will become kx, if I add up, kx plus rho ag x.
It is FB plus T now, sir.
FB plus T. Oh, okay, yeah. Thank you for correction. This should be called small m plus capital M into E. So this will become rho L. It is rho L. Rho L Ag small m plus capital M into X. So this acceleration will be opposite to displacement. It will get confused. That's why I'm avoiding that negative sign. So how is this acceleration will be acted opposite to acceleration? So therefore, this will be example of SHM. So therefore, omega equal to K plus rho L Ag by small m plus capital M. Now look at the buoyant force. Is it a conservative force? Yes, it is. Spring force is a conservative force. What about the work done by tension? Net work done by tension is 0 here. That's why we can also solve by conservation of mechanical energy here. How the questions can be asked here is, rather than asking time period, more than one options. If the density of liquid is increased, then the time period of oscillations. I think you can take care here. Able to get this. If the area of cross section of the block immersed increases, the time period decreases. You see all the parameters are there. Spring constant increases. Then if this is doubled, this is halved. I'll make it this 2 times. This I'll reduce by off. Then what happened time period? So more than one options instead of asking time period, because time period means everyone knows. They'll ask you about these queries. You have to what you should do. You should come back here. And you have to fight with this equation. Through this equation, you can analyze very easily. So buoyant force is a conservative force. So now when the block is oscillating, regarding the nature of work done by the buoyant force, we'll see that it is at equilibrium. When I depress it and release, it does positive work. Then when the conservative force does positive work, then potential should decrease. What potential will decrease? The potential of the liquid will decrease. Gravitational potential of liquid will decrease. So how the work done by buoyant force and gravitational potential of liquid are? They are opposite. If buoyant force does positive work, potential of the liquid decreases. Gravitational potential. If the buoyant force does negative work, gravitational potential increases. I think so many things are there, no? Here. So many queries can be asked when FB does positive work, gravity potential in G decreases. When FB does, buoyant force does negative work, gravity potential in G increases. Net work done by tension here. In fact, it will be 0 here. Please do analyze. These are very important. Studying like this is something very important. Don't end up just with answer. What's going on? What all happening here? SHM is the best topic again to revise all of your mechanics. I'm making clear, or all of physics also, except modern physics and optics. The remaining all things you can revise with help of SHM. So many numericals are there with this one. So they're the best topic where you can revise 80% of physics syllabus. Let's take the next question. If they postpone things like this, no, very difficult for me to teach to bring new problems. The data is there, but keep on discussing that. To be frank, another, I think 5 months is what I can continue. After that, I definitely say that I don't have anything new. Work done by, so when the when the block moves down, work done by buoyant force will be negative. When the block is ascending up, work done will be positive. Okay, the plates, each of area of parallel case, I'll expand it. Some are telling not visible. Just to see, we had a problem where the spring is outside the plates of capacitor. Now I just took a problem where the spring is inside the plates of capacitor. The block is released from rest. The maximum elongation of the spring. Okay, we'll do one thing. Shall we get into the work energy concept? Decrease in gravitational potential G of the block should be equal to work done by electrostatic force of attraction, because this plate is fixed here. This plate is fixed here. You can see clearly. This plate is mobile. So decrease in gravitational potential of the block is equal to work done by spring force plus work done by gravitational attractive force. Now the work done by electrostatic attractive force between the plates. I think straight away, if you go there, okay, fine. Somewhere after this, can we calculate the maximum speed? That also we can calculate. So now they are at rest. At extreme point, what is the state of them? Will be at rest. So then how the situation will be. I need again diagram. Okay, now what are the forces that will be at extreme point? So it has come to instantaneous. So what are the forces that will be acting here? Electrostatic attractive force. Spring gets elongated. Kx. Can we equate forces? No, at extreme point, you cannot equate forces. Hope everyone remembers the small basic ideas here. At extreme point, you cannot equate forces. Diagram. I'll bring the better diagram. Huh? This is the plates of capacitor. There's a block. Some rough diagram. Go for. Let's get into this one. So here there is a spring is there, no? Then what are the forces that are acting here? At equilibrium or at extreme point, we'll directly go for it. So electrostatic attractive force between the plates. Spring gets elongated. Say some tension. Anyway, this I'm not bothered. Okay, let this be the tension. Now, what is the state of this? This will be at instantaneous rest. Very next moment, it will start accelerating up. So therefore, you can't. Or say, what is the situation here? This will be at extreme point. It will have acceleration. So therefore, you can't equate the forces. Similarly, here also. This plate is fixed, no? And it will have a charge plus Q minus Q. Can you equate forces? No, there's the biggest mistake what everyone will do. When block is executing SHM at extreme point, can you equate forces? No, only at mean position you have to equate forces. It's asking maximum elongation of spring. So how come the spring got elongated? When the block has descended by distance x, then only possible here. So the decrease in gravitational potential G is equal to work done by spring force, work done by attractive force between the plates. This sentence is very important. Decrease in gravitational potential G of block M is equal to, or we'll write here, the work done by spring force plus work done by attractive force between the plates. So then the decrease in potential G equal to how much? Let it be mgx. Work done by spring force, it does negative work. Then negative work only, the increase in elastic potential here. Then this the electrostatic force, it also does work. How much it will be? F into Ex. Maximum elongation of spring. I think this is what maximum elongation, what we calculate. So this is equal to Kx by 2. Now what is Fe? Q square by 2A epsilon naught. Solve for this, you'll get the required answer. He's asking maximum elongation. So mg minus q square by 2a epsilon naught equal to kx by 2, or x equal to 2 by k. Simple problem. We have all the problems where spring was outside the capacitor. Now there's a problem where I brought where the spring is connected between the plates. We can manage here. So there's a maximum elongation I'll call. Okay, now after this, let T be the time period of oscillation. Then how you manage this question here. So at equilibrium, so there's a maximum elongation. So how much elongation at equilibrium will be off of this? I think you know in SHM basic ideas, the elongation at this point will be off of it. The elongation like at equilibrium portion should be off of the maximum elongation. So therefore what we can conclude here now, at equilibrium, I'll equate the forces. Then if I slightly displace, what will be the Fe? Will remain constant. Tension will become internal force. Mg the constant. So what is the only additional restoring force? That is only spring force here. At equilibrium, let it be there. At equilibrium, F equal to Kx naught minus T naught equal to 0. T naught minus Mg equals 0. If I slightly pull this block, then Mg will remain constant. Okay, tension will change. Let it be T. Here this will be T. Here Kx will come, no? Kx naught plus x. So I think I'll better write equations. At equilibrium, we are doing there's the first part, the second part. Second part of the problem we are doing. At equilibrium, Kx naught I'll make it a little bit nip-tick. Kx naught plus Fe minus T naught equal to 0. T naught minus Mg equal to 0. Now when the block is slightly displaced and released, then what do we get? Plates are having anything mass?
Massless.
No, massless, that one. The left plate is connected to vertical wall to massless, that one. Only the plate mass, assume the pulley to be massless, neglect, connected to a block. So if you just go for if you add up this total, it will be this T. Okay, no problem. We'll write M dash. Then this will become T minus Mg equal to Me. I think M dash is 0. And T will get cancelled out. So the resulting equation will become only Kx equal to Me. M dash is 0 as plate is massless. You need not to get scared. Nothing, very, very simple equation it is. Okay, fine. This expression for the time period. If Q square equal to 2m A epsilon naught G, then what should be the elongation of the spring will be? Should be 0, no? According to this equation, we got the maximum elongation, we got it. If Q square is equal to 2m G by A epsilon naught, it will cancel out, no? So the elongation will be 0. So what will be your answer? This will be your answer. Can be done. Very, very simple problem it is. Now I can bring some friction between the plates. Then so many other things will come. You can analyze now. So nothing to do. So what is the force of interaction between the plates? It will remain constant. It's independent of separation between the plates. That's why we took Fe here. So instead, what students will do is like you will go for energy in the capacitor. Okay, fine. You will get the same answer. But your problem will become very simple when you go for force of interaction between the plates. This one. One more Fe, I'll show it. So that will be easy for you. We know the force of interaction between the plates depends only on the charge and area of cross section, independent of separation. I'll take the next question after this. Let's see that how you think on this. It's there in many books, but the solution you'll never understand. Am I right? If you want to go and check it, it's there in many books, but solution you find very difficult to understand. That's why I just picked up it. Okay, this is M1. We'll indicate like this. Symbols will be easy for us. Yeah. Okay, this will be M1. This will be M2. Okay, think on it. Meanwhile, I'll set the diagram. Yeah. Okay, no, have a diagram. I think you have to draw a diagram. By seeing not possible. Nobody can solve, even myself also. You have to draw the diagram. Let this be alpha. This is what our question is. What has to be done for this? The approach is very important. What approach has to be taken? Look at the one end of the spring is connected to block. The other end is connected to a wall, and that wall is again in turn connected to wedge. Okay, no. Okay, let's assume that one. Let R be the displacement of block with respect to wedge, and let the wedge have displacement x2. What is R? XR, we can also write it as XR. What is XR? Displacement of block with respect to wedge. And what is X2? Let it be displacement of wedge here. This one. So this X2 is what? Like with respect to ground, XR is this one. I think these are the very primary things which are very important. What is XR? Displacement of block with respect to wedge. You can get into the problem very easily from here. Let's go for conservation of mechanical energy. Then initially, what is the state of this? There'll be some spring force will be acting. The kx0 will balance m1g sin theta. Okay, agreed. This will be initial spring force. Now I'm going to slightly pull it down and release. Then this is the additional. This will be how much I'll pull down. Let me pull down by distance xr with respect to wedge. Then what makes the wedge to move? Because of normal contact, and the wedge will start moving here. Let x2 be the displacement here. Now if I differentiate this dx2 by dt, what do I get? I'll get the velocity of the block or the speed of this wedge. Similarly, if I differentiate dx by dt, dxr by dt, speed of the block with respect to wedge. I know speed of the wedge. Can I bring the other quantities? So here, first we'll calculate the displacement of block with respect to ground along x and along y axis. So it will be x1, x will, for that, it will be xr is equal to xr cos theta, displacement of block with respect to wedge along x-axis. Yeah, it should be equal to, that should be equal to displacement of block with respect to ground. All right, only x1, it is understood. It will be towards left negative. Okay, if I take this is positive, this you have to take it negative, minus of minus x2. So what is this x1x? Displacement of block with respect to ground along x-axis. Oh, this is, I think, xr already is there, no? Along x-axis, xrx. Hope I think I have. So what is xrx? Displacement of block with respect to wedge along x-axis. That should be equal to displacement of block with respect to ground along x-axis minus of displacement of y. Why negative sign? This will be towards left positive, towards right negative. I'm picking. So this should become equal to xr cos alpha. This we don't know. So x1, if you are interested, you can go for x1x. That will be better. This will be, and this is the that of the wedge will become plus. So I came to know now xr cos alpha plus x2. Similarly, xry, displacement of block with respect to wedge along y-axis should be equal to displacement of block with respect to ground along y-axis minus displacement of wedge with respect to ground along y-axis. What about this? This will become XR sine alpha. This is unknown thing. This will be 0. Why 0? Because the wedge will not move along y-axis. Wedge will move only horizontally. That's why it is 0. So I got x1y and x1x. If I differentiate these things, dx1x, what do I get it? Speed of the block with respect to ground along x-axis. This should be equal to dr. Okay, first what you have to get the expression. Okay, in terms of that will end up, okay, this will become cos alpha dxr by dt minus velocity of the wedge. Let me write v2, and this relative velocity, let me write vr. One step will write in detail. This is the first step. In books it's there, but actually the written final answers you find very difficult to understand, and that's why I just picked up. This is what like v1x only. This is vr and this is v2. If you want, you can directly go for it. Let the velocity of the speed of the block with respect to wedge by vr along the incline. Then similarly, v1y will take it. So this should be equal to vr sine alpha. Differentiating this equation. Okay, now I can write an equation. So now what is the equation we can write here? The energy equation, I'll take help of it. And what all form the energy is available in the kinetic energy of the block? mv1 x square plus mv1 y square plus that of the wedge mv2 square by 2 plus elastic potential energy of the spring. What shall I write elastic potential energy? kxr, you have to write it. Because already, sir, why you are not taking the gravity? m1g sine theta will be balanced by kx0. If I further displace it, I'll be displacing it with respect to what? With respect to wedge, no? So how much further elongation of the spring? Equal to xr. So displacement of block M1 with respect to wedge or increase in elongation of the spring from equilibrium position. Both are same. This is okay. Let me add now. The sentence will be much easier for you to understand. What is XR means? Or increase in elongation of spring from equilibrium position. Now what to do? Okay, finally we got it. Shall we differentiate this? Shall we differentiate what to do with that XR? What to do with XR? XR will become VR. V1x will become A1x. This will be A1y. So I think I had to work out some relative motion here. Conservation of net. So what is the net force acting on the system? So I am bringing it like this. So this will be N1. Now I'll bring the forces here. Then M1g sine theta. So this, okay, this will become K x0 plus xr. So somewhere in the corner we'll write it. Kx0 is equal to initial elongation of the spring should be balanced by m1g sine theta. Now we'll differentiate this. What we have to do, we have to find out the frequency of small oscillation. Either you replace v1x in terms of v2, v1y in terms of v2, the problem will be solved. But what to do with xr? So I need some relationship. So again, I'll come back to this one. V1x, we can write it as the same equation already we have here, no? These things I'm going to take help of. Can we write directly this equation or not available? I am just leaving it to students. Can you write this equation in this way? The best question is what your teacher is asking. So is this equation justifiable? Yes, very much. No, we are differentiating now. No, what we want, we need. So all our unknowns are there. All these are unknown. So I'll go for conservation of linear momentum. From the conservation of linear momentum, so initially the system was at rest. So this will become m1 v1x minus m2 v2. What is v1x? V1x equal to Vr cos theta minus v2 minus m2 v2. V2 is equal to m1 Vr cos theta by m1 plus m2. Okay, now what I can do is I'll replace Vr in terms of V2, V1x in terms of V2, V1y in terms of V2. Then I'll differentiate. Sir, what you are going to do with XR? XR also should be replaced, no? XR should be brought in terms of X2. Able to make it out? So this will be, so now we'll solve for Vr. Cos theta, cos alpha, no, it is. Yeah, this is the one primary equation which is going to help us a lot. Now, what I can do is like this Vr, I'll substitute it, I'll get V1x, V1y. Okay, already this Vr is there. Vr I'll substitute here. Oh, sorry, this Vr I'll substitute here. Then I'll get V1x in terms of V2. This Vr I'll substitute here. Then I'll get V1y in terms of V2. So I brought everything in terms of now what like V2. If I can show that wedge is executing SHM means even the block also will execute SHM. After this, what to do with this? This if I differentiate, what do I end up? dxr by dt. dxr by dt is nothing but the Vr, no? If you want, you replace this xr by x1y by sine alpha. Problem will become very simple. Then you differentiate. Then where all dx1 by dt will become v1y. Hope everyone is able to understand this one. In the books, what happened? Directly they wrote some equations, very difficult. Nobody can understand, but there's a procedure here. Let's do one thing. Replace first xr is equal to in the old equation. So here, yeah, I'll bring this. XR, what I can write it as? X and y by sine alpha whole square. Now we'll differentiate this. The overall energy has to remain constant. The overall energy has to remain constant. So differentiating this equation, can we replace better? I think we can go for V1x in terms of V2. Then again V1y in terms of V2. So I should, I'll write equation 1. One, 2, 3. This is the 4. So what you should do now? substitute 1, 2, 3 in this and get everything in terms of E and so like a x1, y is there. So what is x1, y? Again, I have to show that negative displacement, what we have to bring? We have to bring x2, I think. Oh. Something went wrong here, no? I have to bring x2 into picture, not x1, y. Again, we have to take help of this. XR in terms of x1x. Again, we after differentiating x1x has to be replaced. So many calculations are there. Huh? Okay, I think now x1, y. I think this will be not advisable. Huh? Because again, we'll end up with this one only. This is not advisable. I will go for some other thing. This one will better replace XR in terms of this one, x1x minus x2 by cos alpha. Then because I have to bring V2 and x2 into the picture, then we'll get x1x. Again, we have to replace x1x, no? Then again, you have to bring the same equation. Then you have to replace x1x in terms of x2. I'll do one thing. I'll bring this later on. Let me write one more equation. Similarly, can we write even XR is equal to, problem will be solved here only, y2. Hope everyone is able to understand. I think this will be a very easy approach. Okay, this XR we got. Now we'll replace XR. Everything is available in terms of now V2 and X2. We can solve the problem very easily. First, you have to substitute 3 in 1. Then we'll get V1X in terms of V2. Substitute 3 in 2. Then you will get V1Y in terms of V2. Substitute 4. Then we'll go for all the substitution. Let me solve this now. So V1X, put 3 in 1.
M2 V2 by M1.
M2 V2 by this much. Huh? Alpha will be there, no? Okay. Only this one will come. Now, similarly, V1Y.
Sir, M2 V2 by M1.
V1Y will be VR sin alpha. So M1 plus. How much you'll get it?
M2 V2 by M1 only.
This
V1X, sir. V1X, sir. M2 V2 by M1.
M2 V2 by M1. Huh?
Yes.
V1Y.
M1 plus M2 by M1. V2 tan.
M1 plus M2 by M1 tan alpha.
V2 tan.
V2 tan alpha. Yeah, put 3 in 1, put 3 in 2. Okay, now everything we have in terms of V2 and X2, there will go and substitute. Then the primary equation will write it some equation A or something. So these are the 5, 6, 4, 5, 6 in A.
Sir,
I
got time period expression, sir.
I'll put 4, 5, 6 in A and differentiate. We are differentiate with respect to time. With dE by dt must be equal to 0. Equating this all solving, look at the equation. What is the equation you'll get?
Sir, time period equal 2 pi into under root k into m1 plus m2 by m1 m2 plus m1 squared sin square alpha.
Okay, fine. I'll write the omega. I have answered. K by M1 M2 by M1 plus M2 cos
Plus
square
M1
alpha
square.
cos square alpha plus M1 sin square alpha. You should get this much only. Then only differentiating and equate to 0. So here, what is the other things like dv2 a2 is equal to dv2 by dt. And you have to show that acceleration a2 is negative proportional to negative of displacement minus x2. This will be your final equation.
Sir, or else we can write K into M1 plus M2 by M1 M2 plus M1 square sin square alpha.
Okay, further simplification. Yeah, it can be
Yes,
done.
sir.
Yeah, that'll be better. M1, M2. Okay, it can be further.
Into-
Yeah. I don't have place. I'll leave it here. This I'll send it to numerator. then M1, M2 I'll take common.
We'll get sin square alpha plus cos square equal to 1.
Go to 1. Again, one more sin square alpha will be left over.
Yes,
Okay,
sir.
Yeah, fine. Okay, correct. Okay, just I brought it so that so many other ideas are about a wedge constraint, the conservation of linear momentum. See, once we'll take the next question. Read the question. We have a gas is filled up here. It is what gas is present. That blue color one is a piston. Very easy problem. You have done SHM with 2 springs. You have done separately SHM of like a gas piston of mass m, like it encloses the cylinder. Then the cylinder is slightly depressed exhaust. So now we are just bringing both the things. Some constant equation is introduced here. Nothing big. That is what happens in final exams. Slight change in the things what you learned. First of all, so we should get the constraint equation. So how the displacement of piston. Okay, this will be the gas. This is a piston. So we'll assume that one. Let the displacement of piston be x. Elongation of the spring be x1. This will be x2. First, we should get the constraint equation. Then later on, the spring forces will act here. K1 x1. This will be K1 x1. This will be K2 x2. K2 x2. And here, how much of spring force? 2 K2 x2. So first, the net force on the pulley must be 0. So the tension, because the same string is there. So these two spring forces must be equal. So from here, K1 x1 is equal to K2 x2. Then next again, what is the constraint equations? We can write it here.
X equal to x1 plus x2.
X equal to x1 plus x2. No. Let me try. Let's assume that this spring is not there. let's assume that here one string is there. The spring is not there, we'll assume it. Then if this pulley moves by 1 meter, then here 1 meter, here 1 meter will increase. Then how much this will elongate by 2 meter. So therefore, the displacement of this is the displacement of the spring is twice of this, or this is half of it. So constraint equation. If I move this point by x meter, then here one x meter will increase. Then how much this will elongate by 2 times. So the displacement elongation of spring is twice of this, or the displacement of block is half of the elongation of spring. Similarly, assume that this spring is not there, only string is there. Here let there be spring. Then if this pulley moves by 1 meter, here 1 meter will increase. How much this will elongate by 2 meters. So therefore, what is the displacement of piston? Half of it, half of elongation of spring 2. X equal to x1 plus x2 by O divided by 2. So from this, we'll get equation for x1 and x2 in terms of x. We'll solve this. So let me substitute here now. X1 is equal to, after substituting this, 2k2 x by k1 plus k2. What about x2? X2 will be 2k1x by k1 plus k2. Then directly we'll go for what we have to supposed to do here now. Initially, what are the things? So let's come to the piston. No, this part is over. Let's come to the piston. The weight of this will act, and initially a pressure force PA. Then the tension in the string. Okay, how much it will be? 2k k2 x2. When the piston is in equilibrium, when the piston is in equilibrium, the volume of gas in the cylinders is V0 and its pressure is P0. Okay, this much is, I think we can write it here. Now, if I slightly displace it, what conditions will arise? The weight mg will act as it is. The pressure force will get incremented, P0 plus dP by A. The increment in pressure force, I'll take it. Then here, how much of this will be 2k x2 plus x. X is what? Oh, this is some other displacement. We'll write it R, no problem. So how much it is pressed by distance x. What is the type of cylinder? Adiabatic cylinder. And whatever the piston is also adiabatic. What process the gas will undergo? Will undergo adiabatic process. The gas will undergo here adiabatic process. If the piston were conducting or this particular tube were conducting, then it would have been isothermal process. The gas here will undergo the adiabatic process. So now, we have to get relationship between these things. Now, what is the restoring force that will act here? The overall restoring force. When you press this piston slightly down and release. So what you are doing when you press this slightly down, the springs will get elongated. So spring force will change. Okay, let R be the. So what is R? I think this will become X only, no? No. It should be R only. So let R be the elongation of this spring. We'll take that one. So this, I think I'll write Y. This will be a better idea. How Y and R related? Again, we'll think in the similar way. Now, what is the additional, like it will accelerate up. So what is the additional restoring force that is acting? dP into A plus 2Kr is equal to Ma. Hope everyone is able to understand. So there's a restoring force that is acting. What to write with a dP? So what process the gas will undergo? In fact, the gas will undergo adiabatic process. So dP is equal to minus gamma P by V into dV. If you can, I think you should remember all these things, they will help you. So what is further? dV is equal to A into Y. So like this, the Y is brought into the picture. dP, I'll substitute there. What to do with R? R is the additional elongation. So I think we have this relationship. If the piston moves by X, the elongation, further elongation, the spring 1 and 2 are given by this one. If the piston moves by Y, similarly, shall I take help of this same equation? So how X, R and Y are related? They're related by this equation. R is equal to 2K1Y by. Are you getting now why initially I brought this? Without this, I don't think so you can do anything with R. No, this dP value I'll substitute there. So, and everything this should be positive, will add up. These are restoring forces. Magnitude is what I have to substitute here. Why magnitude? Because both are acting in same direction. This is from mathematics is what I ended up. PV gamma equal to constant, you have to substitute only magnitude. So this will become gamma PV AY A plus 2K R will become 2K1Y by K1 plus K2.
That is K2, sir.
2K2. No, X2 value, X2 value. Here 2K2. Okay, no? So I think we got acceleration as a proportional to negative of displacement. So gamma P A square V plus 4 K1 K2 by K1 plus K2. This is proportional to negative of displacement. So therefore we'll end up with omega. Okay, fine. These are the some problems. Later on, you write P naught V naught. The pressures were P naught V naught, no initial pressure. You have to be. I think the most troublesome will be the getting between relation between R and Y. This is what the concept will help you. And just make observation. I'll go for the next concept. This will be our answer. The best topic SHM, I'm telling this one, it's the best topic to revise the most of the physics. But you have to work out problems on mixed concept, not only spring block. So many are there. So spring block mixed with some other thing. Mixed concept better in SHM. The best topic, especially for advanced, may not be for mains. Mains, again, just kinematics of SHM, simple pendulum, compound pendulum. More than enough. Better mains, don't read anything, directly go for exam. One more very good condition, I have brought it. Read the question. It's really a little bit some trick is there that you have to make observation here. Yeah, no. I think that this was the problem. What is the initially? What are the various forces that will be acting? I'll just show spring. This will be enough. The rod is massless. I think this is a very important part of the problem. Assume gravity to be absent. Two very important things are the rod is massless and gravity to be absent. Now the block is slightly displaced and released. Is asking find the time period of oscillations of the system. We have three springs, K1, K2, K3. The problem, the gravity is not there. So what has to be done? So now initially there are no elongations or compression. Now you are going to you are just going to pull the block and release. Then you have to find out the time period of oscillation of system. Shall I say that the spring will not come into existence because only these two forces are acting on block. So they will decide the time period of oscillations. They will decide time period of oscillation. So this will not there. And how they are, it is similar, but this point is not a fixed one. If this point were fixed, okay, we'd have thought just they are in parallel, K1 plus K2 would have been. Since this point is also movable, because of that, K3 will come into picture. Okay, now I'll begin this. So let this mass be displaced down by distance x. Then the spring will undergo compression, and theta be the angular displacement of the rod. Then what is the compression in the spring? Because this length is L by 2. So we'll write the data. Let x be the displacement of block in downward direction. We are going to give it. Then the rod will rotate. So then the compression the spring. So we'll write here. Then the compression in the spring is equal to how much? It should be equal to x minus L by 2 theta. Both upper end and the lower end of the spring will undergo displacement in same direction. Since we have pulled it, so definitely there is a, sir, why can't it undergo elongation? No, we have the moment if we pull this block down, what is the probability of spring? Well, first this end will move down, no, then this end also will move. So it will not elongation, it should be compression. So this end will move by 2 centimeter, this will move by 4 centimeters. So how much compression? The difference of that is what we are expressing here. But what is the forces that are acting on the rod? We will bring the rod into picture. This is a rod. So here spring force will act. K2, it's a compression, no? So compression force, how it should be? K2 into say some R, I'll write it. The compression in the spring, let this be equal to R, will write it. K2 R. Then who will balance this torque?
K3.
K3, this one. So here, what is the tendency? This, the other spring force, this will be. And what is the rod is light. So therefore, what should be the net torque on the rod? Should be 0. I think now we can. L is equal to K2R into X minus, okay, K2R into L by 2 it is. So K3 X3 is equal to K2R by 2. What is R? R is X minus L theta by 2. Okay, let me substitute. K2 by 2, R will become who is undergoing displacement? The block. So what is the problem here? Theta and X3. What is X3 equal to? Shall we write L theta? This X3 should be equal to L theta. Look at the rod. So this I'll substitute there. I'll get relation between X and theta. So solving this, we have to solve again this one. K2, 2K3 by K2 by 2 into L theta equal to K2X. So expression for L theta will be 2K2X by 4K3 plus K2. Why X3 and not K3? X3. Displacement of this end should be equal to L theta. Okay, if the rod rotates through angle theta, what is the linear displacement of this?
Sir,
Because
but both are in opposite direction, sir.
no, this will get compressed. No, the spring will compress. That's why spring force is acting. Are you looking at this?
Okay, sir.
Huh? Okay, somehow this equation is there, so we will give some name for it. One will write it. Now, but what you have to calculate? You have to calculate you have to show that the acceleration of the block is proportional to negative of displacement. Shall we write equation now? Shall we write equation? Again, what is the problem is like a L theta, everything we have brought it. L theta equal to 2kx2, that one. So what is the net force acting on the rod? That will express it. So the acceleration ma equal to, I'll write everything in red color. No, what shall we write here? K1, how much is the block? This, if the block moves by x, how much it will elongate by x? So what is the restoring force will be K1x. What about here? How much of compression? I'll give, let me draw the diagram and explain it. It will be easy for everyone. Here, how much of spring force? K1x. It is being compressed, no? So you'll get a spring force. So what shall I write this K2 here? Anybody? R, no? K2 R only, no? So then how is the acceleration? So this acceleration is proportional to negative of displacement. So therefore, minus ma equal to K1x plus K2R. Okay, now this will be K1. Let me don't disturb x. Let me disturb R. So what you can write R as x minus L theta by 2. So then we don't know L theta. L theta is what you can from the equation 1. K2 x minus 2K2x 4K3 plus K2. So solve for now. Energy method, try it, you'll be in a very big trouble. Otherwise, I have proposed it. So it's not that you will not get answer. You have to struggle a lot. K2, this will be 4K3, K2 minus K2. So this will be K2 by 4K3 plus K2 into X. Then acceleration will be proportional to negative of displacement. K1, 4K1, K3 plus K1, K2 plus 4K2, K3 minus K2 square by 4K3 plus K2 into M. This is everything equal to negative of this.
Sir,
K2, yeah.
in the third equation, it should be x minus K2XL.
2K2x, no?
Sir, L theta by 2, no, sir.
L theta by 2. Okay, only K2x will come. Oh, yeah. L theta by 2. Only K2x will come. Only K2x will be 1 K2 square will get cancelled.
K2 square no.
Will not be there. Okay, okay, yeah. Thanks for correction. So now the time period is given by I think as you bring the different types, no, the rod, light rod comes, okay, little bit complication. Just be careful about the light rod. Okay, I think a lot of some constraint equations came into picture. That's why the problem has become little bit. We have to be extra alert. That's all it's telling. Sir, what is the possibility of asking S in passage? They will ask not as objective, as a passage. I'm making things clear. They will balance time very systematically in advanced exam. They can't just dump this as objective, but in weekend exams, I do dump because we don't have any specific thing. No, we just see question and where it is, timing, parameter, nothing. Teacher in our institution, we don't bother about that one. Okay, this. So look, have a look at once. If rod is having a mass, tell me what changes you are going to bring. If the rod is having a mass M. If the rod is having a mass M.
mg4 comes in.
Then again, the problem will totally change. But this constraint equation, okay, will come into picture. Then here, you not get it. Equal to 0, not possible. How do you get in? So will there be, what about SHM? There is a complications there. Now what will happen? Only when they are in resonance, they will have the same angular frequency. Otherwise, may not be possible. That's why the rod is made light. If the rod is having a mass, no, then the answer what you solve may be one of the situation. I think when 2 blocks, 3 blocks are connected, we had no, the similar condition will arise here. Yesterday I had been to vaccine, almost I think morning 7 o'clock I went and stood in the queue almost till 2 o'clock I was in a queue to get vaccinated. So again, almost 6 hours I stood in the sunlight to get vaccine. So I could not take class. Vaccine nearby our this one area. Karmanghat area, there it was given for us. So I booked long back. Yesterday I got a slot. So even after booking, the slot was that much of time. It was a huge rush. Tomorrow I'll continue. I think we have ray optics and wave optics. We'll stop the SHM here. Tomorrow I'll bring with the ray optics numericals. Then again will get a time on Friday. I'll bring the ray optics and the wave optics will take it. At least one day, one topic will have a slight touch. That will help us a lot. Those who have notes, no, please send like a message me. I could not respond because so many things are there. After 6 o'clock, after 5, you send message. I'll send it. This notes, I'll send it. Tomorrow you have exam. Huh? Which exam? Tomorrow is a Thursday.
Part test.
Tomorrow Wednesday or Thursday?
Thursday, sir.
Thursday.
So today is a Wednesday. Huh?
Yes, sir.
Yes.
Today, Wednesday.
Okay, then on Friday, I'll go for the optics. At least we'll take the optics questions. Oh, Monday we had a paper discussion. No? Then Tuesday I could not attend. Okay, there's a Wednesday. Please just after 5 o'clock, you can just ping me. I'll send these notes. This may help you. Some 5 problems we have discussed. Okay, we'll meet again. Thank you, all of you.
Thank you.
Try to revise all the problems related to the exams, part test, mains, everything is there. No, don't solve any new problem. Recollect all the things. Just take my notes, everything. I think you have a app, still more very easy. Recollect all, just this question, what is the method? Could not understand the notes, come back to the video, check that particular part. Okay, what is the concept involved? Come on, don't wait for complete solving. Like that, you can revise number of numericals. So if you revise number of numericals, that clarity will come. So you can do better in exam. Okay, bye, see you. Take care.